Hi, 7th graders. Today's lesson is 6.2.2, Checking Solutions in the Distributive Property. Make sure you've showed your teacher your completed homework and you have your book out ready for today's lesson. You can pause the video and then play again when you're ready. First, the opening is 6.2.2, How do I know that it is correct? Checking solutions in the distributive property. Sometimes a lot can depend on a solution of the problem. For example, when businesses calculate the cost of packaging and shipping a product, they need to come up with an accurate value. If they miscalculate by only 1 penny per package, but ship 1 million packages per year, this small miscalculation could be costly. Solving a problem is one challenge. However, once it is solved, it is important to have ways to know whether the solution you found is correct. In this lesson, you will be solving equations and finding ways to determine whether your solution makes the equation true. 660. Chen's sister made this riddle for him to solve. I am thinking of a number. If you add 2 to the number, then triple it, you get 9. Build the equation on an equation mat using algebra tiles. What are 2 ways that Chen could write this equation? Okay, so I am going to make, that's the wrong one, an equation mat, just using a square. And I need to create this equation using algebra tiles. So I'm thinking of a number. If you add 2 to the number, then triple it, you get 9. So if I'm thinking of a number, I'm going to say my number is x because it's an unknown. So the way I'm going to show that is by making an X tile on my paper. So these are the same things you should be doing in your notebook. It says if I add 2 to it, so I'm going to add 2, and those would just be unit tiles. I'm just going to add 2 unit tiles to it. Those are positive, so I'm going to shade those in. And then I triple it. So I have to have 3 of those. I'm going to do it the quick way. You need to draw this out on your paper. All right. So it says, I'm thinking of a number. So x is my number. I add 2 to it. So I add 2, and then I triple it. I get 9 total. So it's saying that that is equal to an equation mat that has 9 on it. So you need to make a second equation mat that has 9. It would be really nice if you had the duplicate feature in your notebook, I'm sure. 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. So if you need to pause the video and catch up with me, feel free to do that. Okay, and I'm going to show that these are equal with an equal symbol in between those. So A is asking for 2 ways to write that. So one way I could write that is I could have x plus 2. And if I'm going to triple that, I'm going to have 3 of those. Equals 9. Another way I could do this is using the distributive property. So I'm going to say I have 3 groups of, remember the parentheses means groups of, 3 groups of x plus 2 equals 9. So that would be A. B says, solve the equation and show your work by writing the equation on your paper after each legal move. So for this, I'm going to write my equations under here. So I'm going to have 3x, another way to write it is 3x plus 1, 2, 3, 4, 5, 6, plus 6, and that is equal to 9. Okay, so now it's telling me that I need to simplify with legal moves. So I don't have any negative tiles to cancel on this side, but what I can do is I can do balance sets. So I can balance one unit from one side with one from another. I'm going to go back and forth doing that. Okay, so what I did there is I took 6 away from my left side, which makes it mean I take 6 away from my right side. So that would be the same as subtracting 6 from both sides. So now I'm going to end up with 3x, and I can see that in my picture, is equal to 3. And after I do that, I'm going to solve my equation, and it would mean that one of these x's equals each one of my tiles on the right, and that would be the same as dividing them into groups. So I'm going to divide each side by 3, and that would end up meaning x is equal to 1. So each x equals 1 unit. So that would be your answer for B. So you need to show the moves and you need to show the work with the equations. C says, when Chen told his sister the mystery in the riddle, she said he was wrong. Chen was sure that he had figured out the correct number. Find a way to justify that you have the correct solution to part B. Okay, so now for this one, the way you do it is you have to replace x with 1 in one of your equations. So if I go back to A, I need to prove that x is equal to 1, so I'm going to replace x with 1. So I'm going to use the distributive property 1 here. So if I write 1 instead of x, I would have 1 plus 2 inside the parentheses here is equal to 9. Okay, so now if this is true, this side should be equal to 9 also. If I think of order of operations, I need to do the parentheses first, so my 3 will remain, and then I add what's in my parentheses is 3, and that should be equal to 9. And you'll see 3 times 3 is 9 equals 9. And so I know that it is true, and I can prove it to Chen's sister. When you are asked to justify that you have the correct solution, the way you do it is you solve for x, and then you put the value of x back into the equation to show that both sides are equal to each other. You'll have to remember that when you get to tests and quizzes in this unit. 61 is the next. Now solve the equation 4 times x plus 3 equals 8. Remember to build the equation on your equation mat with algebra tiles. Simplify the equation using legal moves, record your work on paper, and solve for x. That is, find the value of x that makes the equation true. So if you think that you have this, I would like you to pause the video and try it on your own. If not, I'm going to go through this step by step right now. So first I'm going to start by drawing an equation mat. This says I have 4 groups of x plus 3 equals 8. So I know that both sides are equal to each other, so I'm going to draw the equal sign in between. Now I'm going to draw 4 groups of x plus 3. The way I'll do that is I have 1x plus 3 and all of those should be shaded because those are positive. And now I have 4 groups of those. So I'm going to duplicate those 4 times. You need to draw 4 groups of them in your notebook. So I have 4 groups of x plus 3. So x and 3, x and 3, x and 3, x and 3. So your paper on the left should look the same as mine, is equal to 8. So on the right side, you have to have 8 tiles. All right, so once yours looks like mine, if you need to pause for a second, feel free so that you can get all of those drawn. If not, I will keep working on this. So it says simplify the equations using legal moves. You'll notice that on each side I only have positives, so there's none to simplify on each side, but I can do balanced sets with one unit from one side with another unit from another. So I'm going to go back and forth as many times as I can with my unit tiles. I can cross those off because those are equal on each side, and I'm trying to find out what's different here. All right, so I'm simplifying using legal moves. I end up getting down to 1, 2, 3, 4x. I'm going to write that beneath it. 4x plus 4 is equal to 0. So now I need to solve for x still. And if you remember, the way you solve for x is to get x by itself. So in this case, x is by itself already on the left side, but I need to move all of the other numbers onto the right. So the way I'm going to do that is to do the opposite. So instead of adding 4x, I'm going to subtract 4x. But if I do that to one side, I also have to do it to the other. So by subtracting 4x, those will simplify. I'm left with 4x. Make sure you're doing this on your paper with me. Equals negative 4. Now I need to get x by itself. So the way I'm going to undo 4 times x is I'm going to divide by 4 on both sides. Yeah, so the 4 divided by 4, that cancels to 1. So I'm left with x. Negative 4 divided by 4, I end up with a negative 1. So solving for x, x is equal to negative 1. And the way I'm going to go back and find out if that's true is I'm going to plug negative 1 in for x in my equation of 4x plus 4 equals 0. So if I do 4 times negative 1 plus 4, that should equal 0. 4 times negative 1 is negative 4 plus 4 equals 0. And if you see, a positive 4 and a negative 4 do equal 0, so I can prove that my equation is correct. That being able to prove it is an important step. All right, 662, checking your solution. So I'd like you to read through this problem on your own and try it by yourself first, and then play the video when you're ready. A, hopefully you already realized that we did this together. So we plugged our value of in for x and show both sides were equal. And if we look back at our problem, both sides were equal to 0. So that proves the equation. Then for B, you had to solve each person's problem. For Kelly's work, you should have negative 3 equals negative 3. For Madison's, she had negative 3, and that does not, negative 9 does not equal 3. So Kelly ended up with negative 3 equals negative 3. That means her answer is correct. Both sides should equal if you got the correct value for x. And that means x is equal to 2 because that's what she put in for x to find negative 3 equals negative 3. So whatever value you put in for x, that is your value, the answer for x. In D, we had already done together. Okay, now I'd like you to finish problem 63 and 64. After you finish those, you need to show your teacher, and that is your ticket to get your homework 65 through 70. Have fun!